This is the next part of simplification lecture where we're going to talk about DeMorgan's theorem. In the last section we talked about simplifying equations when they only had single lines over single variables like a naught or b naught or c naught. We didn't have lines over multiple variables. So in this section we'll see how DeMorgan's theorem works with lines over multiple variables. DeMorgan's theorem says that large bars can be broken up into smaller bars over individual variables. That way we can work with individual variables instead of the things underneath them. We really can't do anything with them if the bar goes over multiple variables, so we have to break those up. So basically what happens with De Morgan is when you break a line, you change a sign. So you see in our examples here, I've got A and B and C with a line over top of the whole thing. Well, if I break this line right here, if I break this one where my arrow is, you can see it's going to be, it's and underneath that line. We'll break the line and the and becomes an or. And then the line now is just over A. Break this line and that and becomes an or, and we just have the line over B and then over C. So we break the line, change the sign. Break the line over ors, they become ands, and then the lines are split into three different pieces. So it's a way for us to get rid of these bigger bars and break them down into smaller ones. So we'll do some examples here. This is pretty much what I just showed you, but I wanted to show you a little bit bigger, a little bit where you can see a little bit better. Here's A and B not. So we've got AB with a not line over top of it. This, if we want to do De Morgan's theorem on that, you break the line right here, and then you change the sign underneath it. Since it's an and, we're going to change it to or. So we broke the line and changed it from an and to an or. So AB naught is the same thing as A naught or B naught. Same thing with A or B naught equals, break the line, change the sign, so or becomes and, A naught and B naught. So break the line, change the sign directly underneath where you broke the line at, nowhere else. So let's do this one together. And for this one, if you look, these lines are already broken. So the best thing I could do here is break the line right here. If I break the line right there, right underneath there is an and. So we're left with A naught, B naught, and then there's the line I broke right there. So I got the A naught and the B naught, and there's the line that I broke in half. Or becomes and remember double inversions, if you have two things that are knotted, like A naught naught, it just becomes A. So that equals A, B. So that's the same as each other. They're equal to each other. If you look, yes, I could break this line and then break this line and then break this line. But if you look, if I break the line right here, it's going to create a line that's the same length as this one. And this line is going to be just covering those two. So I would have two lines that were the same size, which means I can now cancel them out. So let's see what that looks like. I've got A naught, and then that or becomes an and, B or C not, and then here's the line I broke, not. Lines the same length, the lines are the same length, I can just cancel those lines out. There's no reason to do anything else. So it's A, and then keep parentheses around things that have lines over top of them that you cancel. That way you keep them together. So you've got B or C. So A and B or C. You can multiply it through to see if it'll go in simpler, but I don't think it will, but we'll do it just to be sure. So you got AB, and then you got AC. No. So either one of those, you do either that or that. Either one of them are correct. I'll take either one of them. So try some of these. Break the lines up and see what happens. This one, you'll need to break it there and there. So make sure you change the line there. And make sure you change you change the sign there, and make sure you change the sign there. See how you do, and come back and we'll see the answers for them. Okay, here's the answers for them, and let me go ahead and show you how to work out some of these. If you break this line right here, you're left with A naught naught, B naught. And so the two lines cancel, you're left with A, B naught. This one, you break the line there, you've got A naught or B naught naught. Two lines cancel, you're left with A naught or B. Here, we're going to break that line right there. It's A naught naught or B, or C naught naught. Double lines cancel, so you're left with A or B or C. You can drop the parentheses since they're all ORed together. This one's a little more complicated. You can break them one at a time though, so let's go ahead, just break this one right here first. So we're left with, again, use parentheses to keep things kind of stuck together. A naught, B naught, and then this is going to be AC naught naught. And then we need to break this line. So we've got A naught naught or B naught AC, because two lines cancel each other out. And that actually equals that one. Now we may be able to actually go even simpler. Let's do A times AC and AC times B. Let's see if we can go any further. So AC times A is AAC. And then we've got AB naught C, right? AC, B naught, A, B naught, C. The two A's go just to AC or A, B naught, C. And we can pull an AC from both these, can't we? So you're left with 1 or B naught. All that cancels out, you're left with AC. So it did simplify a little bit. For this one, let's break the line there, and we're left with A, B naught, naught, ended with C naught, naught. Well, the two naughts can go away, and break the line there, and we're left with A naught or, because we changed the and to an or, B naught naught. Two lines cancel each other out, and we're left with C and A naught or B. And I multiplied it through just to show you that it really didn't make it any simpler. So hopefully that helps, and we'll move on to the next one. And if you need to pause it or go back, then do so. Now you may remember from algebra doing a FOIL, first, outer, inner, last. And all FOIL is a method of reminding you that you need to multiply certain things to each other so you won't forget anything. If you want to think about it, FOIL is just taking this one times both of these, and then taking the second one times both of these. Okay, so you got first, outer, well that's times both AB times AC, AB times BC, and inner is BC times AC, and last is BC times PC. So you're just taking AB times both and BC times both, and that's all you're really doing. So let's work through this. And you've got AB and AC. We're going to take and do these two first. So if you do those two first, you've got AB, AC, and I'm writing them down just like I would multiply them. And then we do a plus, and then we're going to do BC and AC, AB and BC, the outer ones. And we're going to do the inner ones, AC, BC, or BC, AC. And then we're going to do the last ones, BC, BC. Now if you go through and combine like terms, like A and A goes just to A, so you get rid of one of the A's. A, B, B, C is just A, B, C, because anything ANDed with itself is itself. A, B, C again, right here, get rid of the two C's and just put them in alphabetical order. And B and C just turns into BC. So that's this line right here. Then from there, if you look, you've got a BC in every one of these. There's a BC in every one of those, so that's a like term. So if we pull out BC, we're left with A or A or A or 1. Because you pull BC from BC, you got 1. All this stuff cancels out, you're left with just BC. Give you a second to look that over, see what I did, and then I'll go on. Biggest thing is there's no squares in Boolean algebra, so there's no a squared or b squared like you would would you fill out normal algebra. Now this is the truth table, and I didn't ask you to fill it out because it's a really big truth table, but I did want to show you what it looks like. You'll notice here that I started with, we've got A, B's, and C's in here, so I just have a 3-variable truth table, which means I have 8 lines, 0 to 7, and I need the variable AB, I need an AC, and I need a BC. And then my simplified is actually BC. So I already had it here, but I like to put it at the end. So I did BC over here. And so we need to do our original. Our original, the first one we need to do is fill out the AB, the AC, and the BC. So we're going to AND these two columns, and these two columns, and then BC is ANDing these two columns. So that's how I got these. Then I'm going to do the first one. It's got AB or BC. Well, there's AB. There's BC. It's an OR, so I got a high there, and a high there, and a high there, because I've got two high. Either any high gives me high, not both highs. Sorry. And then this one, AC or BC. So that's this one and this one. So ORing those, any high gives you a high out. There's a high, there's a high, and there's a high. And then the last one is to AND these two together for right there. Two highs gives you a high out. So this one would be high and this one would be high. So that's my original. And then the simplified one is going to be just BC. We already have it over here, so I just copied it over. And they're equal to each other, so that's great. We're done. That's all you need to do. So it's a little bigger truth tables. You may have some bigger truth tables, but they are equal to each other, so we know we simplify correctly. Last thing I want to mention is bubble pushing. And bubble pushing is another way to do DeMorgan's theorem in pictures instead of doing it with the logic diagrams. The Boolean algebra. With the Boolean expressions, we can actually do it with logic gates. And the deal is that when you bubble push, you change the gate, which is the same thing as changing the sign, and any bubbles that are there, you take away, and if bubbles aren't there, you add them. So let's look at an example. So there's my original, and you can see I've got two AND gates and an OR gate, and I'm going to bubble push this last one. And for all the problems I'm going to give you, really all you have to ever do is bubble push this very last output gate, and that'll fix all the rest of them. So if we bubble push this gate becomes an AND gate, right? OR becomes an and there were no bubbles on any of the inputs or outputs, so I'm going to add bubbles to all three, both inputs and the output. Well, these bubbles on the input could be just as easily back here as they can be up here. Doesn't matter which side of the wire I invert on, but this is not really a gate. But if I move these bubbles back, they say float the bubbles back on the wire, then you can see I've got three NAND gates. So I've basically taken it from an AND chip and an OR chip to a one single NAND chip. So I saved the company probably 20 cents per circuit just by doing that bubble pushing right there. Each chip is about 20 cents. So instead of having two separate chips, now I only have one chip. So we're going to an example with the AND gate. And again, take this AND gate, bubble push it, so AND becomes OR. There were no bubbles, so add bubbles. Float these bubbles back to there, and now we've got all NOR gates. Again, saved another 20 cents. But if you're making 1 million boards, that 20 cents adds up quite a bit. Try this one on your own and pause it right here, and then I'll go on to show you the answer here when you're ready. Okay, this is the answer, and let me just show you how I did this. If you take this last one, remember we're not going to do anything to the input ones because I said just do the last one. So those are not changing. But what's going to change is our last gate. So this OR gate is becoming an AND gate. We had a bubble there, so take the output bubble away, and we didn't have bubbles there, so add bubbles to the inputs, just like that. These bubbles float back, and then you're left with a NOR, a NAND, and an AND. Now, does it make sense to bubble push this one? Maybe not. You know, it may not make sense to actually bubble push this one. Maybe it would be this way, but there are cases where you need to bubble push. This was just a good example of kind of manipulating all of them together. Okay, practice these, pause the video, come back when you're ready. Here's the answers. And again, bubble pushing, OR becomes an AND, float the bubbles back to make them OR gate or NOR gates. In this case, the bubbles actually cancel out. So Let me show you. So for that one, I've got an AND with bubbles on all of them, and here I've got NOR gates with bubbles on the outputs. Well, what happens when you got two inversions? Two bubbles cancel each other out. Not and not just turn into just a regular line. There's no bubble at all there. So they cancel each other out. For here, the bubble floats back once you change it to an OR. And this one, the AND becomes a NOR, and float the bubbles back.